In this lesson, we're going to use the cosine law to solve for an unknown angle as well as an unknown side length. It's important to understand how to recognize when you're going to be using the cosine law. And first, we'll deal with a situation where we're asked to find an unknown angle measure. If you are given a triangle where you have the three side lengths, so you have a side, side, side triangle, and you're asked to solve for an unknown angle, then that is a situation that would require the use of the cosine law. You'll notice that there's no 90-degree angle in there, so you can't use primary trig with SOHCAHTOA. You'll also know there's no way of establishing a complete angle side length pair, so you can't use the sine law. So you are stuck with the cosine law. You'll notice that the cosine law can be written in three different ways, depending on the angle that you're trying to solve for. In our triangle, you'll notice that we do not have any vertices labeled, so we can go ahead and label them whatever we like. So why don't we just label this vertex A for the unknown angle? That will make things fairly straightforward. And C, and the next step after we label the vertices is to associate the sides with those vertices. So you can see that angle A, side A is opposite that, angle B, side B, and angle C, side C. Okay, well that means that if we are trying to solve for angle A in this case, then we are going to use this version of the cosine law, and I can write that as cosine of angle A. So in this case, I will just write theta is equal to, and on top we have the length of B, 7 squared, plus the length of C, 10 squared, minus the length of A, 15 squared, and all of that divided by 2 times B, which is 7, times C, which is 10. Okay, so that means that the cosine of theta is equal to, and we'll just pull up our calculator, 7 squared plus 10 squared, subtract 15 squared, and you'll notice my use of brackets to ensure that the total numerator is evaluated before I divide it by the denominator, which is 2 times 7 times 10. So please make sure that you are careful when you're using your calculator to evaluate the total numerator and then divide it by the denominator. When I get that, I get a value of negative 5,42857. Now the calculator has told us that the cosine ratio is equal to negative 0.5428571429. And that means that theta will be equal to the inverse cosine of that measure, that negative 0.5428571429. Now on our calculator, if we just leave that value on our display screen, we can very quickly just ask for the second function cosine, which gives us the inverse cosine, and then just ask for the answer that was previously on the screen. And that results in an angle of 122.878 degrees, 122.878. So theta equals 122.878. We were asked to find theta to the nearest degree, so this is going to then round up to 123 degrees. In the second example, we're going to work through a problem that will require us to use the cosine law to solve for an unknown side length. Now this is a word problem, so first we're going to have to sketch the triangle that represents this problem. And after we sketch it, we'll take a look at the triangle and I'll explain why we need to use the cosine law in this situation. So let's give it a read. It says 2 fishing boats leave Olympic Harbor in Kingston at the same time. One boat travels at a speed of 19 kilometers per hour for 2 hours, reaching its destination in Lake Ontario. So let's say that there is Kingston Harbor, okay, the Olympic Harbor, and the first boat is traveling out to here to its final destination. There we go. And it travels at a speed of 19 kilometers an hour for 2 hours. All right, so if off on the side here, if we say 19 kilometers per hour times 2 hours, that's going to give us 38 kilometers traveled. So the length of this side is 38 kilometers. Okay, the next boat heads on a course 70 degrees from the first boat and travels at a speed of 14 kilometers for 3 hours, reaching its destination. So off we go on this next boat. It finally reaches its destination down here, and 2 things have happened. One is it has traveled 14 kilometers per hour for 3 hours. So let's do that calculation. We've got 14 kilometers per hour times 3 hours, and that's going to be 42 kilometers. So I'll put that measure on that side. And the other interesting point was it said on a course 70 degrees from the first boat, which means that 70 degrees is right there. Okay? Then the question finishes up by saying, how far apart to the nearest kilometer are the 2 boats when they reach their fishing spots? So we are being asked to solve for this distance here in between the 2 boats. Okay, so this is the unknown side length that we're asked to solve. So let's go ahead and label this triangle, and I'll just label this A, this vertice B, and this vertice C. We'll label the little sides as well, so A is little a, B is little b, and C little c. Okay, so let's remind ourselves of what the cosine law for a side looks like. And that's what it looks like. And again, we have 3 different versions, and notice how we're solving for little a, little b, or little c, which are the side lengths. So what would lead us to believe that we need to use cosine law to solve this problem? Well, anytime we're given 2 side lengths, so for example, if we are given a side length on a triangle, another side length on a triangle, and the contained angle, so a side, an angle in between, and another side, that is cosine law. Okay? We cannot use SOHCAHTOA, primary trig, there's no 90 degrees. We cannot use sine law because we have no complete angle side pair. So in this case, again, it's a candidate for the cosine law. We are going to use the side version where we're solving for a side, and it's as simple as just making sure you plug in the values properly, and we'll just solve for the side length of little a, which is the distance that the boats are apart. So a squared is going to be equal to b squared, and little b was 42, plus c squared. Well, c was 38, so 38 squared, minus 2 times little b, 42, times little c, 38, times the cosine of angle A, which was 70 degrees. Okay? Now, this looks pretty complicated, but if you just enter this into your calculator, if your calculator is one that has a display where it shows you the entire calculation, then you press enter and you get the answer, then your order of operations will be done properly by the calculator. If you have a calculator that does not show you the entire equation before you press enter, then you have to apply the BEDMAS rules on your own, which means that you would have to take and complete this section first, get a value, and then square this, add the square of this, and then subtract whatever this value you achieved in blue was. but we'll use a calculator that does allow us to put in the entire equation. Okay, so opening up a calculator, we'll go ahead and we'll put in this equation and we will get an answer. So I'm going to say 42 squared plus 38 squared subtract 2 times 42 times, 42 times 38 times the cosine of 70 degrees. And that equals 2116.27. So a squared equals 2116.27. Now, that's a squared. That isn't the value of a. So we need to say that a is equal to the square root of 2116.27. Now on the calculator, if we leave that answer of 2116.27 on the display, then our solution becomes very easy when we're looking for just the value of a. I'm just going to ask for second, the square root of the previous answer. So it will take that previous answer with all its decimal accuracy and it will find the square root of that for me, and it turns out to be 46.0029. So there we have it. Now, it did ask for the distance that the two boats were apart to the nearest kilometer. So I can see that A is 46.0029. Therefore, A equals 46, which is rounded, kilometers. This is a word problem. So typically with word problems, we'll write a finalizing statement and we'll say the boats are 46 kilometers apart. Okay, so there's a couple of examples on how to use the cosine law to solve for an unknown angle measure, as well as use the cosine law to solve for an unknown side length. And just make sure that you can identify those two situations where you require the cosine law. For an angle, if you are given all three side lengths and no angles, cosine law. For a side, if you are given two side lengths and the contained angle in between them, and that's it, cosine law is your only law that will help you get started on solving that triangle.